Hi, welcome to Avocet Math. In this video, we're going to look at another problem from our set of AMC12 counting problems. So let's take a look at what we have. Mr. and Mrs. Lopez have two children, but when they get into their family car, the two people sit in the front and two others sit in the back. Either Mr. Lopez or Mrs. Lopez must sit in the driver's seat. How many seating arrangements are possible? So let's imagine our car with its driver's seat, passenger seat, and two back seats. And what we notice from the statement of this problem, the driver's seat is somewhat special in that one of the two adults, let's call the adults 1 and 2, must sit in the driver's seat, and the children must not sit in the driver's seat. So essentially, in choosing the driver as being driver number 1 or driver number 2, we notice that there are two possible choices for picking the driver. Now, having chosen the driver, the remaining adult basically forms a pool with the two children to form a total pool of 3 passengers, which then have to occupy one of the 3 passenger seats. Now, it appears as though these 3 passenger seats are distinct, and we have 3 items to place into these 3 distinct passenger seats, and that appears to be a permutation problem. We have 3 distinct items to place into 3 distinct seats, and there are 3 factorial ways to accomplish that. And it appears also that regardless of which driver we choose for the driver's seat, the remaining driver will constitute a permutation set of 3 factorial choices. So even though there is some linkage between our choice of the driver and the actual people that appear in the passenger seats, the total number of arrangements of the passengers is independent of which driver we actually choose. And so we can still apply our multiplication principle for counting the number of compound sets, and we can discover that the total number of arrangements of people to satisfy that one of the adults sits in the driver's seat is 2 times 3 factorial, which is equal to 2 times 6, which is equal to 12, and that is choice B. It's instructive to also examine the case where we look at the more normal situation or more usual situation where we have a car where the 2 adults are always going to sit in the front and the 2 children are always going to sit in the back. That certainly was the case when I was growing up. And this is a somewhat simpler counting problem because we realize there's only 2 ways to arrange the adults. We can either put one adult there, one adult there, one adult there, one adult there, and likewise for the back seats. So there are 2 ways to choose the arrangement of the children. There are 2 ways to choose the arrangement of the adults. These are independent choices that don't connect in any way. We can use the multiplication principle to count the total number of combinations as being 2 times 2 for a total of 4. So anyway, that's another interesting take on this problem, and we'll see you at the next video. Take care. Bye.